Hi, I'm here today to talk a little bit more about circuits and different types of circuits. There's three maybe, main types of circuits that we're going to deal with. And there's some similarities and there's some differences in how they operate. So series circuit is where all the components are in a single path. And I'm going to show you what that looks like in a second and compare it to parallel circuits. And parallel circuits are multiple paths, basically where electricity has the option to follow different paths and will split. Like some of it will go down one path, some will go down another. They don't always split evenly. It really depends on the components of the circuit that you have in there. But the electricity will split paths. And then sometimes you have what's called a hybrid circuit. That's a combination of series and parallel components. And as long as you follow the rules of series and parallel circuits, you can understand how a hybrid circuit works. We're going to look at specific examples and problem solving, different kinds of circuits, finding current and voltage and resistance in a future video or future videos. But three main kinds of circuits. Let me show you the difference now between what a series and a parallel circuit looks like. So this is falling. Okay. This shows you two circuits. One is a series circuit and one is a parallel circuit. So if you look at the series circuit here, you'll know there's a battery and three resistors and some wire. And that's it, right? And all three resistors are in a single path. So when electricity leaves, positive current leaves this side, goes through this resistor, goes through this resistor, goes through this resistor. So the electricity in this goes through every component in this series circuit. This is different than a parallel circuit. In a parallel circuit, you've got positive current going this way. Remember, electrons go the opposite way. But positive current goes this way. It comes to a junction here. And when it reaches the junction, it has a choice. It has a choice to either go down this way or to go out here, boom, and then they both reconnect here and end back at the original place. So this is what a parallel circuit looks like. You guys want to come in?
Can we view the video?
Yeah. We have a couple guests here, Mike and Nicole.
Wait, I'm coming.
Okay. Now they're going to hold up what is called a hybrid circuit. Here we go. You want to hold this? So a hybrid circuit, this is a hybrid circuit with three resistors and a battery. And I've labeled the resistors R1, R2, R3, and R4. I would stand back just a little bit because the focal plane, like stand in front of the board.
Okay.
Like this.
Oh.
And just look a little
Me? Okay.
not awkward. Try to do the Vanna White thing. Okay. There's the battery, right? Positive current flows this way. It flows through R1 and R2. All the current flows through R1 and R2. So those are basically series components. Then it gets here, boom, and it has a choice to either go through R3 or R4. And some of it will go down this path, and some of it will go down this path, and eventually it will rejoin and go back out and hit the bottom of the battery. So positive to negative. Good job, right?
Yeah.
So that's a hybrid circuit. You can put that down if you want. Let's talk about a little bit of the different application of circuits. You realize that I might have to remake this video every year with new students. Okay, so we've talked about voltmeters and ammeters a bit, right? Voltmeter with the letter V, ammeter with the letter A, and we connect them differently. So we connect voltmeters as a series circuit, and we connect ammeters as a parallel circuit. Let's put this down just for a second so I can write on it. So if we're connecting a voltmeter as a parallel circuit, let's say we just want to use the voltmeter to find the voltage of R2, right? If we want to do a voltmeter around R2, we got to put it there. And remember, the voltmeter measures the voltage drop. So if you're dropping voltage, you need to measure a starting and an ending point. So you're going to see how much it drops between those 2 points, and you're now measuring the voltage of R2. If we wanted to measure the current through R2, remember all the current comes down here, and then the current splits, and some of it goes there and some of it goes here. So we need to put an ammeter someplace to measure the current only where it goes through R2. So we could put an ammeter there, and that ammeter would measure the current just through this path, right? Not through this path.
Why
So
are we doing this?
when are we doing it?
Yeah.
I can't tell you exactly, because then I can't reuse the video, right?
Oh,
I'll be like, we're doing it on April 24th, and then it won't be April 21st.
We're on camera, Nicole.
A little while, right? Let's say instead I put an ammeter here. Remember the ammeter is in series with everything. This ammeter is now measuring the current through the total current, some of which goes down R1 and some of which goes down R2. So that is the total current. If you wanted to measure the voltage around R1, you just got to put a voltmeter here, like that. Now instead, let's say you put a voltmeter in the wrong place. Voltmeters tend to have very high resistance, and ammeters tend to have a low resistance. And the reason for that is your voltmeter doesn't want current going through it. So I'm going to simplify this a little bit to just look like this.
You're so annoying.
Me?
Yeah.
Come on. People for years are going to watch this. They're going to be like,
They're gonna love
Mike,
it.
Moss is so annoying.
They're gonna love us.
Okay, and yeah, there we go. So current might go through here, get to this point, and it has a choice. Like you've effectively created a parallel circuit, but you don't want much electricity to go around through this side, because then that would mean that it's skipping your resistor. So you want your voltmeter to have really high resistance. So as little current goes through there as possible. If you put a voltmeter here, you'd basically get no current flow because it's got so much resistance, it would keep the current from flowing. Whereas if you switch that and you put an ammeter here versus here, this ammeter isn't going to restrict the flow of current at all because it's got very low resistance. It just goes right through. But if you put an ammeter here in parallel around the resistor, all that current's going to say, hey, this is the easy path. I'm going to skip the resistor and just go around it, and you're going to overheat your circuit and short circuit it. I think that's about it for now. I was going to add more, but we're going along anyway. You guys want to say any last words?
Thank you for watching.
Wait.
Yeah.
What's... Bye.
Have a good day.
Thanks. Bye.
Can we get our blenders?